continue about polymerization, different polymerization techniques and application of polymers. That is the topic. So keep concentrated all of you so that I can complete the topic today. That polymerization, different type of polymerization techniques and applications. What is a polymer? A polymer is a long chain molecule. It is by the repetition of a small molecule, a chain like formation is there. It's called a polymer, and the individual small unit is called monomer, and by repetition of the monomer we get the polymeric chain. Now these monomers can be same type or multiple different types of monomer possible. If same monomer getting repeated, we get homopolymer, and when you get repetition of different monomer units, you get copolymer. And by the method by which the polymerization is done, it is called polymerization technique. Okay. Now, how many types of polymers are there? Just have a overall idea, because there is a long gap in between. Last class was on 15 December and today is 8th January. So long gap, okay, 3 weeks gap. So that's why I'm just recapitulating all your doubts and everything. So what are the different types of polymer you know? One is called thermoplastic. That can be molded, you can melt it, mold it, make some new material out of it. That is called thermoplastic. Another type of polymer there is called thermoset, which is very hard type. Okay, so after making the polymer, we go for a processing. It is called cross-linking. And after cross-linking, we get a very hard type of material. That is called thermoset. And what is the basic difference? Thermoplastic can be recycled. You can melt it again and again, okay, and remold it. But thermoset, once it is set ready for use, you cannot again melt it. Okay, you cannot recycle it. Thermoplastic can be recycled, but thermoset cannot be recycled. Thermoset, ACT, set. What is thermoset? Example, you have seen tires. Any type of tire, those are thermoset type. Bakelite plastic, that is thermoset. Thermoset means that is, if you apply heat, it will not melt, it will burn. Okay, like this switchboard and switches, that's materials. If you heat, it will never melt, rather it will burn. So that type of material is called thermoset, where you cannot melt it, rather you can burn it. Whenever you apply heat, it will burn, but it will never melt. Okay, so if it cannot melt, you cannot make some new material out of it. So recycling is not possible. That is thermoset. Why it is not becoming possible? Because these molecules are interlinked among themselves. That is called cross-linked. The molecules are called cross-linked molecules. So if there is a cross-linking, if you apply heat, this cross-linked molecule cannot be separated properly, in a proper fashion. Some of the bonds are broken, random fashion. So, and if you give more and more heat, higher and higher temperature, rather it will burn, but properly the bonds are not broken, and that's why thermoset could not be recycled. Okay, take so many examples there. Thermoset. One is bakelite, I told you. Now tire, rubber, cross-linked rubber. Cross-linked rubber, they are called thermoset. Thermoplastics, polythene, polypropylene, this type of material, which can be quite easily melted. You can melt it quite easily. Okay. Now what is monomer? The unit. By repetition of this unit, you get the long chain. That is called monomer. Now sometimes what you get, a few number of units joining together forming a block. Okay. Monomer A, monomer A, monomer A joining together. Again monomer B, monomer B, monomer B. So this is called unit, block. So block A, then block B, then block B, block A again. So this type of things is called block polymer. A few number of monomer units gathered together forming a block, and some other monomer units gathered together getting another block. So block A, block B, again block A, block B, repetition, you get block polymer. Sometimes what happens, these monomer units are arranged in a very regular fashion, A, B, A, B, A, B, that way. They are called regular copolymer. Copolymer because A and B, two different monomer units are there, so copolymer. But it is regularly arranged, A, B, alternately placed. So it is called regular copolymer. Sometimes we can get irregular. A, then B, then A, then B. There is no proper arrangement. So in that case we call irregular copolymer. So regular, irregular, block, different type of polymers are there. Achha. According to this thermoset and thermoplastic, as I told, so this is called thermal property. Thermal property of a polymer. Okay, thermoset and thermoplastic, this is thermal property of a polymer. Similarly, we can classify polymer according to their source, natural and synthetic and semi-synthetic. Natural polymer example, rubber, your wood, the cellulose, starch, cotton. Cotton is a cellulose material. So these type of materials which are actually obtained naturally, protein. So these are natural polymer. Out of these natural polymer, some of them are available from biological organisms. They are called biopolymers. Okay, so all the biopolymers are natural polymers, but all the natural polymer may not be biopolymer. Biopolymer means organism is biological organism. It is coming from some animals or plants, obviously. But sometimes it may not, if it is a natural polymer, but it is not from animal or plant, that is also possible. So that is called natural polymer, but may not be biopolymer. But biopolymers will be always natural polymers. Some are synthetic. Synthetic polymer. Hey, তুমি কি করছো? What are you doing? What are you writing? Listen to me, huh? Okay. Don't do anything else. Achha. Synthetic polymer, for example, polythene, polypropylene, bakelite, nylon 66, nylon 6, whatever different type of polymer we have heard about. So these are all synthetic because these are not naturally obtained. Naturally, carbohydrate, protein, these things are natural. And synthetic, polythene, polypropylene, these things are synthetic. Sometimes what we get, modification of some natural system into according to our need or our requirement. Some modification done. So it is called semi-synthetic. For example, you take cotton, dissolve into NaOH. After that, this dissolved, that some portion is insoluble, so just filter it out. After that, the filtrate, take the filtrate and add some acid. Immediately there will be precipitation, and that precipitated form is called alpha cellulose. So this cellulose only, the cotton is fully cellulose, alpha, beta, gamma, delta, different type of cellulose units are there. So these cellulose units, it dissolve, a portion dissolve and the rest of the thing is not soluble. And the portion not soluble, you discard by filtration. Whatever there in the filtrate, add some acid and you get the precipitation. That is called alpha cellulose. Now you can filter it, wash thoroughly, and out of that you can make some your dress materials. That is called rayon. Have you heard about rayon? So this is rayon. That means it is how do you make it? Get it originally it is from natural, but ultimately you are doing the modification, and so it is called semi-synthetic. Modification you are doing, so it is called semi-synthetic. Cellulose is natural. You are doing some modification, doing cellulose acetate, cellulose diacetate, cellulose triacetate, some sort of structural modification you are doing. Then it will become semi-synthetic. Okay? Because sometimes we need that. So naturally, if you want to use, why we just interested about natural polymer? Because it is biodegradable. Most of the time natural polymers are biodegradable. So if it is biodegradable, you can freely use without any hassle. Otherwise there will be hazards, isn't it? If you take some synthetic, some artificial thing, and if you discard in the environment, after that, that polymer or plastic is not mixed with the soil very, very long time. So that polythene packet that we are using for shopping, most of the time it is very bad. It is hazardous. It is taking 45,000 years to mix with the soil completely. Okay? though we have heard about some plastic eating polymer now, that plastic or polymer eating bacteria microbe nowadays, but it is not sufficient. Very little bit here and there, stray away it is there, but plastic is still is nuisance for our society. So polymer is good. It is very much beneficial. We have a lot of advantage of polymer. It is quite convenient, right? If you want to just buy 2 kg of potato, so you ask for a potato poly bag, right? So that is a very fantastic thing. We are always using it, but the problem is that environmental hazard. So how to avoid that? Biodegradable. Some nowadays in the market it has come. You will find in the any shopping that particularly online shopping, if you give some order, you get in the biodegradable poly bag. Okay, white color or off-white type of color, it is written, I am not a plastic. So that is biodegradable polymer. So polymerization is a technique. Different type of polymerization techniques are there. Addition polymerization technique there, condensation polymerization technique. Addition polymerization technique always occurs into non-polar solvent. Non-polar solvent like SOCl2, DMF, carbon tetrachloride, chloroform, methylene chloride, methyl chloride. This type of monomer, this type of solvent we are using. These are called non-polar solvent. Now in this non-polar solvent, if you take monomer unit like ethylene or propene and do the polymerization, what do you get? Polythene, polypropylene, propene, okay, polybutadiene. This type of polymers, they are all undergoing addition polymerization technique. And what is addition polymerization technique? Addition means what? A plus B equal to C. That is addition. So here, ethylene plus ethylene. Ethylene dimer. Then 3 unit trimer. So if you have a multiple units, polymer. Okay. So 1, 2, 3, 4, one after another, just getting joined, forming a long chain. The number of monomer units into a chain is called degree of polymerization. Okay, so many monomer units are getting joined together. So the number of monomer unit into a particular chain is called degree of polymerization. DP, a very famous term. DP, degree of polymerization. The number of monomer units into a chain. Now, when you do the polymerization, is it always necessary that chain size will be same? Never. You have a very small chain, you have a medium chain, long chain, very long chain, isn't it? Different type of chain fragments will be formed when you do the polymerization. That's why we have if you want to go for your molecular weight if you want to measure, or molecular formula if you want to get, how do you do that? You have to always take the average. Because the chain length is never equal. When you go for a monomer, all the size of the molecule is same. NaCl all are same. Okay? If you take acetic acid, so acetic acid is CH3COOH, all are equal. But about polymer, cannot say that. Very small, medium, long chain, very long chain, and so on. So that's why your molecular weight, or if you want to calculate, it will be always average. So there are 2 types of average molecular weight. One is called number average and one is called weight average. Okay. So degree of polymerization already discussed. So let's go ahead. So this is addition polymerization and condensation. Let's go ahead with that. What is addition polymerization? It is also called the chain polymerization. Chain growth. And condensation polymerization is called step growth. Chain growth means ethylene molecules joining together, and it is happening always in a very fast manner. And the solvent always non-polar. Non-polar solvent, these ethylene molecules are joining together, giving you polythene. That is the example of addition polymerization. And what is the technique? First of all, some radical will be formed. Radical. So how the radical will form? You have to add something that is called initiator. That initiation step. In the initiation step, we are adding something, it is called initiator, that is a radical generator. So radical generator, what is the formula of radical? R dot. That is R dot. R means alkyl group, and if you just put a dot into that, that represents the radical. So R dot is the radical. How do you make it? Take one example, ROOR. What is that? ROOR, ki bole? Peroxide. Okay. And this OO linkage is called peroxo linkage. So if you take ROR chain and apply sunlight, so you get two molecules of RO dot, 2 units of RO dot. Now this RO dot is what? Radical. So radical is generated. This radical will knock your ethylene molecule. So the reaction is started. So ethylene molecule will break, the double bond will break, and it will have two openings. In one side, RO will join, other side will become open. Then another molecule of RO, CH2 double bond CH2, then another, go on joining. This is called propagation. How the reaction proceed. First initiation, then propagation. Initiation is formation of radical, okay, and then the radical will join to give you some small fragment which will join again and again and again to give you a long chain. This joining process is called propagation. So reaction gets propagated. Propagated means egiye jawa. So it is getting propagated. Reaction is getting propagated. And last of all, it is terminated. So these three steps are there: initiation, propagation, and termination. Initiation is formation of radical, propagation is forming the chain, and termination means ending the reaction process. So all the addition reactions are always happening very fast manner, and some catalyst is required, like, for example, Ziegler-Natta catalyst. Ziegler-Natta catalyst. With the help of this catalyst, radical is generated, and this radical will propagate the reaction, and ultimately it will be terminated, giving you chains. Small chain, medium chain, long chain. These molecules called polymer.
The process end
End কখন করবে? Okay. So whenever your one of the reactant is consumed, it must end. You have given two things. One is the ethylene, suppose. So and another is the radical. So in this case, you have no other option. Only they will join with themselves. Ethylene will join with ethylene, ethylene will join with ethylene. There is no other option. Achha. At the end, how the termination will take place? You can have one chain and it can join with another chain. Both are having the radical ending, the dot at the end. So these two chain can join together directly. So this one just sitting with another one. This is one chain having a radical ending, and this is another chain having a radical ending. Just join together. That is one possibility of termination. Another possibility is that out of these two radicals, one can be oxidized, the other one can be reduced. And as a result, we get alkane plus alkene. That is another option. Okay. And these two are the major options for termination. Initiation, how we are getting? ROR or RCO, R dot, R dash, these type of molecules. And that means peroxo linkage, or it is called par acid. Par acid, you know, RCOOCOR. This type of molecule is called par acid. So it will be broken, means peroxo linkage, whenever there is a peroxo linkage. Why peroxo linkage? Because it is so weak. Peroxo linkage is very weak. So it can break so easily. And that is required. If it does not break, how do you get the radical? We need the radical. That's why we are using that type of molecule which can be broken quite easily with a little bit of heat or light. Heat and light can promote or trigger the formation of radical. Once the radical is generated, then the propagation starts and ultimately termination. So this is the addition polymerization. Okay, I'll show it. It yields a product which is an exact multiple of the original monomeric molecule. Same monomer in it, just getting repeated. Ethylene, 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 you get polyethylene. Propene, 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 you get polypropene. Butene, 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 you get polybutene or polybutadiene. Depending on what monomer you are taking, accordingly you get the product. You can have a combination also. Styrene and butadiene. You get styrene butadiene rubber, SBR. Nitrile and butadiene, nitrile butadiene rubber, NBR. So these are all addition polymerization. Whenever you have a double bonded compound, very simple. Whenever you have a double bonded compound, only one type of possibility there, that is addition polymerization. And when it will make polymer, you have to have the double bond can be a single double bond or multiple double bond, does not matter. But that bifunctional property should be there. It should be bifunctional property because two hands must be open, otherwise chain is not possible. Whenever you want to make a chain, two hands must be open, means the bond must be broken and both sides the chain, addition of the chain will occur. That's why it is called chain growth. Chain is growing, so chain growth. Long chain is forming. Okay, so polythene, polypropylene, polystyrene as example. So you can understand it here quite clearly. Ethene and ethene forming a polythene. Then coming to step growth. Step growth means by condensation reaction. Condensation reaction you have seen aldol condensation, Claisen condensation, Claisen-Smith condensation. What is the speciality of condensation reaction? One molecule joining with another molecule followed by release of a small molecule. Like you have one molecule of organic acid, COOH, and you have one molecule of alcohol. What do you get? Alcohol plus acid giving you ester plus water. That is condensation reaction. Because here two molecules are getting added up. After joining, a small molecule is releasing out. That is released. See the difference. Substitution. One molecule enters, another molecule goes out. Clear? That is substitution. Addition. Two molecules just getting joined. Nothing coming out. Just join. That is addition. Now coming to condensation. Two molecules join followed by release of a small molecule. Acid plus alcohol giving you ester plus water. That water molecule that is getting released from the medium. This type of reaction is called condensation. But if you want to go for polymerization, this condensation will not do. It must be bifunctional molecule. It should have both the ends open, otherwise chain not possible. Condensation you are doing, but it will not give you chain. And if it does not give you chain, you are not getting polymer. So that's why what you need to have, this monomer unit having bifunctional property. Example, adipic acid and hexamethylene diamine. Hexamethylene diamine formula NH2, CH2, 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 NH2. How many CH2? 6. How many NH2? 2. NH2, CH2, 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 NH2. That is called hexamethylene diamine. Then you have adipic acid. COOH, CH2, 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 COOH. How many CH2? 4. And how many COOH? 2. So, both the ends you have COOH group. And in the middle you have CH2, 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 CH2 chain. How many total carbon? 6. So, adipic acid you have got 6 carbon and 2 of these carbon are oic acid groups. And hexamethylene diamine, all are CH2 and both the ends we have NH2. Now, both are bifunctional. One is hexamethylene diamine, another one is adipic acid. Let them do the condensation. This condensation will be called polycondensation because it is not a one. So many monomer unit will join together forming a chain and you are getting nylon 6,6. So that is the best example of condensation polymerization reaction because nylon 6,6 is quite common, it is popular and it is quite, you can utilize it properly. Okay, you have a lot of application. What is the what are the applications of nylon 6,6? Nylon rope, nylon bag, reinforcing material for the tire, lot of applications. Okay, here examples are given, polyester, nylons. Nylon and polyester given. What is polyester? What is ester? RCOOR. RCOOR is ester. So, polyester, that COO group should be multiple number. So in the chain, there will be these C double O groups in the chain, and then it will be called polyester. Let's take one example. You take dioic acid, and you have two OH groups into the molecule. Like, give one example, CH2H, CH2H. What is that called? Ethylene glycol. Now, if you take ethylene glycol plus some CH2H, CH2 and CO2H, CO2H, CH2 and CO2H. Okay, this you let them join to make a polymer. That will be one polyester. That will be one polyester. So polyester is not a single one. There are so many polyesters. Okay. Acha. Polyethylene terephthalate, have you heard? PET, PET jar? PET jar. What is PET jar? Ki kore? Container, food container. Okay. Chanachur rakhte paro. Container. Chanachur rakhar container, plastic container. So that is polyester container. It is called PET jar. Usually food materials we keep into this plastic because it is quite safe. This polyester material is quite safe. That's why this type of material we are using as a food container. PET jar, PET bottle, polyethylene terephthalate bottle, our drinking water bottle. That is PET bottle. Okay, so that is polyesters. Now see that this nylon 66, what I already described. Now let them see. This is hexamethylene diamine and this is adipic acid. So this OH and AH will join together forming one water molecule and it will be going out. What type of solvent will be using here? Aqueous. Aqueous solvent. Solvent may not be much. Without solvent also will do. Solvent always is not necessary. Without solvent also will do. Actually, if you add water from the beginning, reaction will not proceed further because the product is water, and this reaction is reversible in nature. And if you compare with the chain growth, the addition polymerization, it was unidirectional. It is not reversible. Why? Once polymer is formed, it cannot give you monomer back. If you get the polymer will polythene, for example, polythene will not give you back ethylene. That's why it is unidirectional reaction. But here it is reversible. Why reversible? See, this is a chain with this particular bond, which is amide bond, right? This amide bond can be hydrolyzed in presence of water if there is a acid or base catalyst available. And particularly, I have tested nylon can melt easily in NaOH. In alkali, it can dissolve. Nylon rope, piece of nylon rope, you put into NaOH. Even our hair, put into NaOH, it will completely dissolve. But if you take some acid, but I know you are much more scared from acid compared to alkali, isn't it? You are more scared about acid. Oh, acid is very dangerous, something like that. Alkali sometimes can be more dangerous. See, it is dissolves. Our hair is dissolved there, our nail will dissolve there. But HCl, H2SO, no, it will not dissolve. Okay, so it is safer. So, see here, this is a forward and backward reaction possible, reversible reaction there. Okay, that's why if I just take this monomer and this monomer without any solvent is good. Achha. And after that, if you apply little bit of heat is better for the reaction. Why? If you apply heat, this H2 will be evaporated out and reaction will proceed further in the forward direction. Isn't it the principle? If there are multiple products and one of the product if you can remove from the media, what will happen? Reaction will go in the forward direction. So here this is a reversible process. If you can remove this water by some mechanism, then reaction will proceed further. That's why what is the way out? Give some heat. Okay. A bit elevated, not very high, a bit elevated temperature. Maybe 50, 60, 70, not more than that. Very high temperature will be bad. So 50-60 temperature, if you keep this H2O will be evaporated out. It's better. Another thing we can do. Before starting the reaction, we can individually take the monomer and apply heat. Hot monomer we can add. It is called preheating. It's better. Normally we are habituated like this. We add this, then heat. That is not always good. Most of the time, the other technique is better. What I am telling, take the monomer units separately, heat them both, then add them, and thoroughly mix. Don't have to heat further. Enough. So because they are already hot, so reaction will be also very good, and whatever water produced, that will be evaporated, and your polymerization will be immediately started. Okay, and if the polymerization is started, means it is becoming highly viscous. Stirring will be also difficult. Got it? So uniformity will be difficult. Making it uniform will be difficult. So that's why preheating is better compared to post-heating. Could you follow me? Preheating means before adding the monomer, heat the monomer units separately, then add them. It is called preheating. And post-heating, after adding, if you apply heat, that is called post-heating. Preheating is most of the time better for this type of polymerization. Why? Because this mixing is difficult. Whenever you add, immediately the polymerization will be started and it will become viscous. So stirring will be difficult. So better to whatever this heating and all these things should be done earlier and then mix it. Co-polymerization, already you know, different monomer units together. So this is another example actually, copolymerization example. One is, this is butadiene plus styrene, you get styrene butadiene rubber. Styrene butadiene rubber, SBR. It's a good polymer, common, lot of application there. You know, eraser, that is SBR. Now industrial application, acrylonitrile butadiene styrene, ABS, used in the refrigerator. You see, these are applications given where they are used. Nylon bearing gear, nylon giving toughness to the tire also. Polyethylene, flexible bottles, toys, tumbler, mug, jug, bucket. These are all polythene. Mug, jug, bucket. Normally that we are using at our households. Plastic mug, jug. We normally call plastic, but all plastics are not same. Some plastics are thermoplastic, thermoset, different type of plastics are there. What do you mean by the term plastic? Plastic bolte ki boঝো? What do you mean the term? Plastic money. We have some mental mapping into our brain, na? Plastic बोलने से क्या समझ में आता है? What do you understand by from the term plastic? It will be brittle. It will be flexible to some extent. It will break if I bend too much, right? That is called plasticity. That property is called plasticity. And what is elasticity? If you stretch, it will be elongated. If you release, it will come back. So, but every material has got certain amount of plasticity and certain amount of elasticity. Sometimes plasticity is more, elasticity is less. That is true for plastic. And sometimes plasticity is more, elasticity is more and plasticity is less. That is elastic, for example, rubber. But you cannot say it is purely plastic, purely elastic. So every material has got some plastic property, every material has got some elastic property. I can prove. You have a rubber band, girder, যেটাকে আমরা girder বলি. Girder, if you stretch and pull and release, it comes back. But if you keep into some elongated form, if you keep somewhere, fix it somewhere so that it cannot be relaxed back, after a few days, if you take it out, how does it looking like? It will be stretched, elongated, na? Yes. That means it has got plasticity property also. So it has already permanently deformed. So that is called plasticity property. Permanent deformation is for plastics. Achha, and plastic also has got certain elasticity. If I take some plastic and bend, immediately it will not break. Certain amount of torsion it can tolerate. After that, if you release, it will come back. It will not give permanent damage. So that is what elasticity property of the plastic. So plastic has got elasticity property. Elastic has got plasticity property. So they are all property. And whenever you have got one property predominated, dominant property, we call by that name. Plasticity property is more for plastic, that's why we call it plastic. Elasticity property is more for elastic material, so that's why we call them elastic. And plastic and elastic, if we blend together, that is called thermoplastic elastomer. Example, plastic and elastic, we blend it for our purpose. Example, Hawaii chappal. It is thermoplastic elastomer. Got it? Some practical idea you should have surrounding you, what you are using, different plastics we are using, not knowing their property or their name also, isn't it? So that's why you have to be bit more conscious about that. Okay. So different applications, as I told you. Methods of polymerization. Different methods. Coordination, polymerization. Initiation, propagation, termination, as I told you already. So this mechanism I have not shown you. Now let's see the mechanism. Addition polymerization mechanism. This one is cat means catalyst. Catalyst plus this is some ethylene, some alkene, not ethylene, some alkene. Now alkene plus this catalyst, you are getting some radical. Some radical is generated. Okay, so you are getting some radical. The next step, another molecule getting joined, again and again and again getting joined. What you get? The chain. First of all, this is generated in the very first step. Then this molecule, another molecule getting joined. So ultimately what you get? A chain. And we are calling it living polymer. Why living? It can elongate further. It is not ended. That's a living. So this polymer is called living polymer. The chain is not yet closed. It is still open. It is called living polymer. Then termination. As you was telling, how termination will occur? This is termination. So this molecule HX, one hydrogen is somewhere will be less actually. So that hydrogen it is supplying.
Sir,
Propagation. Doing better you are copying because this is giving you some practice, nothing else. Everything is given, but still, if you write it, it will give you some practice. Instead of sitting idle, if you do something, it is better. Next is termination. Termination be by two types. Now these we are calling dead polymer. Living polymer is becoming dead polymer. Why? Because it is no more it is already ended and further propagation is not happening. And when it will be ended, one reactant, some of the reactant must be consumed completely. Suppose ethylene consumed, then how further reaction will be there? Your ethylene is completely consumed. No further reaction possible. Then it must be ended. That is the end. Termination is happening because one of the reactant or both the reactants or maybe the single reactant completely consumed.
Sir, there is an X under CH2 that happened.
Extra CH2 হয়ে গেছে একটা CH2 এইটা হবে না, এইখানে থাকবে, এইটা থাকবে না, এইখানে থাকবে। এটা ভুল ছিল নেটে। আচ্ছা, মেথডস অফ পলিমারাইজেশন। মেথড, so far how many ways, how many types Now coming to method, actual method, how do you do it? What it is called emulsion. Emulsion, you understand? Liquid droplet floating into another liquid. That is called emulsion. So this is called emulsion phase. The reaction is happening in the emulsion phase. Addition polymerization only, but in the emulsion phase. Liquid droplet, monomer unit, that is floating into the surface of some liquid. That is called emulsion technique. In the emulsion phase, the reaction is happening. Too much of detail, I don't want to go into this. That much of detail not required, but just I want to show you how it is happening. So this picture is so, see, the molecules are getting joined again and again and again by this technique. This is, what are the advantages? The rate of reaction is very fast. Fast reaction. And your molecular weight, long chain molecules will be obtained. Fast reaction and long chain. And long chain means strong. If the chain becomes longer, it will become tougher. If you have a small chain, you are getting polythene, but low density polythene. If you have a more number of chain, you are getting medium density polythene. Then high density polythene, ultra high density polythene. Depends on what? Viscosity. And that depends on how many number of monomer units are joining. How much longer is the chain? If the chain is very long, you will get higher molecular weight. Easy heat control. Because this is happening into the emulsion phase, you can easily mix up things. Heat control is also quite easy because it is not very viscous. Get the idea? Another phase is called suspension phase. Emulsion phase throughout the bulk, suspension phase on the top. Reaction is happening on the top, that is suspension phase. Reaction is happening in the bulk, that is emulsion phase. PBC, PMMA, we are getting by this suspension phase. PMMA, polymethyl methacrylate, PBC, polyvinyl chloride. This polymerization we are doing by suspension method. And this emulsion method, it is written PBA, PBC, these are obtained. Now polymer properties. Different polymers are having different properties. I am telling you some property. You have no fiber. Fiber. What is the property? Fiber is very tough. If you stretch, it will not be torn so easily. Nylon rope, for example, you cannot tear it apart. If you pull, you cannot tear it apart. That nylon rope, very tough, na? Fiber material. Fiber. Some materials are called plastic that you can bend and break. So these are the properties of polymer, different nature. Now physical property, mechanical property, crystallinity. So regarding polymer crystallinity, polymers, if you just look at it in detail, inside the polymer, microscopic analysis if you do, you will find some crystals are formed. Overall, what is the nature of a polymer? It is amorphous. Overall, polymers are amorphous in general, but crystals can be formed inside. That is called the crystallinity. If it is becoming more crystalline, it will become hard and brittle. And if it is more amorphous, it will be more flexible. So amorphous is better for a polymer. Amorphous will be better for a polymer. But sometimes we don't need flexibility. We want hard. Isn't it? Sometimes we need more flexibility. Depending on our application, we can have crystallinity or less crystalline material, and physical property, chemical property, all can be changed. You know glass. Glass is amorphous. Glass, কাঁচের গ্লাস বা জানলার গ্লাস, কাঁচ, গ্লাস মানে কাঁচ. So that is amorphous. Now, have you ever seen the glass is becoming, initially it was very transparent, day by day it is becoming translucent, semi-transparent, and after that it becoming very dull and is not at all transparent. Have you ever seen that? That is our practical experience. Now what is happening into that? At the beginning it was purely amorphous. Now day by day crystallinity is generated, and the more a number of crystals generated, light could not pass through, it is becoming semi-transparent, then translucent and non-transparent, opaque. Got it? Because of structure. You know quartz? Quartz শুনেছো? Quartz কি বলতো? Quartz crystal দেখেছো? আচ্ছা, looking like glass, but it has got a regular structure inside. Inside structure you think over. Ordinary glass, internally it is not regular, it is irregular structure. And if you take quartz, it is regular structure. Both are glass, but quartz glass is much tougher. If you by chance, by accident, if you just fall it, it will not break. If you allow it to fall, it will not break. But if you take ordinary glass, immediately it will break. That is the difference. So regular structure gives much tougher property. It becomes much more tough. This amorphous region and crystalline region will be there into all polymers. Some polymer will have more crystallinity, some polymer will have more amorphous nature and less crystalline. But both the property will be inherent. It will be there in all. Any polymer you analyze, you get crystalline property, amorphous property, both are there inside. The structure is like this. Amorphous state, crystalline state. Now coming to molecular rate. Okay, I have to end it because I have environment class. So, okay, let's continue with the environment class.